Okay, kids, section 1.3, practice question 3. Thanks so much for asking this question. We're going to make this direction on the paper north, write down our given information, and right here we're going to call this where the kayaker starts, our initial position, and then the kayaker moves 26 meters north. So we're going to draw that. That'll be the first part of the displacement, the part of the displacement that's all in the north. And while that's happening, it's in a river. So part of the displacement is displacement number 2, which is 36 meters east. So these two things are happening at the same time. I don't want you to think that um, he or she goes straight across and then over. It's moving at the same time. And together, now these two add up to the kayaker being here, final displacement. And then we join initial displacement to final displacement, and that's our total. Now, in the first part of the question, they want you to draw this like with a super amount of precision and scaling. You could do something like maybe, 1 centimeter represents, I don't know, maybe 2 or 3 or 4 meters, and scale this out and make sure it's 90 degrees in here and scale that out. And then to find the answer, you would literally measure this with a ruler and measure this angle with a ruler, and you would get a displacement from a scale diagram. I don't really recommend doing it. Maybe you can do it once in your life, but you know, not a big deal. The main part of this is finding total displacement by using algebra and using the Pythagorean theorem. So the first part here is we would square the first displacement plus square the second displacement, find the square root of all of that, and that would give us an answer. So let's see what we got here. We've got 26 meters squared plus 36 meters squared. The reason I don't have east and west in here, look, I had magnitude signs. Look at these magnitude signs. I'm only interested in the size. Don't care about the direction. So, okay, yeah, so we do the math, and that's 44 meters. Beauty. Now we want to find theta, right? Because it's a vector, so I need to find, this was just the magnitude part of this, right? We just found the magnitude here, right? Now I need to find the direction. So that would be tan inverse of opposite over adjacent. This is a great question. I'm glad you asked it. So tan inverse, well, opposite to this angle is 36 meters. Adjacent to this angle, adjacent means next to, 26 meters. So we got to do some math there. So, we got to do the math here, do the math, and it's about 54 degrees. So now we're going to combine the uh, direction with the magnitude to give us the total displacement, the full-blown vector, 44 meters, and it's 54 degrees. Now look at this angle. The common angle, the common direction here is north. We know that's north, so we can use that as a reference. So this direction in the purple has been shifted away from the north by 54 degrees in an easterly direction. So 54 degrees east of north, and bingo bango, you're done. Thank you so much for asking these questions. Ask more questions, folks, and we'll talk to you soon. Bye bye.